Introduction. Please prepare the following tools before repairing a V8 VRF unit. Cable ties, 1 set of brazing tool, 1 electrical warning sign, 1 safety sign reading "Do not switch on", 1 spray can, 1 measuring cup, gloves, 1 pair of diagonal pliers, 1 set of pressure gauge, 1 Phillips screwdriver, 4 connection hoses for R410A, 1 inner hexagon wrench, 1 monkey wrench, 1 electric screwdriver, 1 refrigerant recovery machine. And I will show you how to maintain V8 units and offer some precautions on it. To recover refrigerant for system repairing, firstly use the tube on the pressure gauge to connect the outdoor unit check valve and refrigerant recovery machine, and set the vacuum mode on the outdoor unit. It will open valves inside the outdoor unit to discharge all refrigerant inside the pipeline. Firstly, we need to enter the vacuum mode. Press and hold the SW5 menu button for 5 seconds, and then press the SW3 up button. Find the serial number 1. Press the SW6 OK button to enter the secondary menu, and then press the SW3 up button. Find the serial number 5. Secondly, press the SW6 OK button to enter the vacuum mode. At this time, the digital display shows R006, vacuum mode code, and 151 current pressure. When the refrigerant is completely recovered, both digital display and the pressure gauge show 0. At this time, the outdoor unit can be powered off. Take photos of the specific locations of each weight block. After the compressor brazing is completed, reinstall the weight block. Otherwise, it is likely to cause the pipe to break. Before disassembling the compressor, remove the acoustic block first. The microchannel tube 1 is the inlet of the auxiliary line and connects to the auxiliary EXV. The microchannel tube 4 is the outlet of the auxiliary line and connects to the injection valve SV8. Before disassembling the electrical control box, use the brazing torch to remove the 4 microchannel tubes. Remove the cable tie of wiring at the bottom of the electrical control box, and then remove the fixing screws of the electrical control box. Removing the weights and compressor wires. In the V8 system, some pipelines use the stainless steel and copper pipe splicing structure, such as compressor discharge pipe and compressor injection pipe. During the repair of these pipelines, special attention needs to be paid to the brazing process. 2. During the brazing process, it is prohibited to use the flame to braze the stainless steel part and the part connecting the stainless steel and copper. Only braze the part connecting copper and copper. Single brazing time must be strictly controlled within 40 seconds. Excessive brazing time may lead to leakage at the joint between copper and steel. After the pipeline is removed, please confirm whether there is a solder residue at the brazing position. If there is residual solder, burn the solder and shake it out. After the brazing process is completed, use a wet cloth to cool the pipeline as soon as possible. Then let's show you how to braze these pipelines. It is wrong to braze the joint between stainless steel and copper. Instead, braze the joint between copper and copper. After disassembling the compressor, it is necessary to drain the oil of the damaged compressor to check the oil quality and oil quantity. First, shake the compressor repeatedly to make the impurities in the compressor fully mix with the refrigerant oil. Then, place the compressor flat and the air outlet facing downward. Use a transparent container to collect the refrigerant oil and record the refrigerant oil quality and quantity. Braze the discharge pipe, injection pipe, and air return pipe respectively. After the compressor is brazed, restore the weights based on the photos previously taken by your phone. If the weights are not restored, pipe breakage may occur. Turn and hang the electrical control box on the crossbeam, fix it with screws, and then braze the 4 microchannel tubes. Make sure that the 4 tubes are connected correctly. When an inverter module failure occurs in the machine and is checked and confirmed to be an inverter module problem, it needs to be replaced. Before replacement, prepare the following tools: 1 inverter module PCB, 1 Phillips screwdriver, 1 Torx screwdriver, 1 pair of taper pliers, 1 pair of diagonal pliers, 1 electrostatic ring, 1 multimeter, 1 heat dissipation silica gel tube. When the module is damaged and needs to be replaced, make sure that the system is powered off. Since the electrical control components take time to be discharged, they may still carry electricity shortly after the system is powered off. Therefore, it is advised to wait for 5 minutes and use a multimeter to measure the electrical control state before disassembling the inverter module. The measurement process is as follows. Use the AC voltage function of a multimeter to measure the voltage of input power supplies L1, L2, L3, N, and make sure the voltage is 0 volts. Use the DC voltage function of a multimeter. Find the CN38 port in the upper right corner of the inverter module. Connect the red probe to pin CN38-1 and the black probe to pin CN38-3. Make sure the voltage is 0 volts. Note that each inverter module needs to be measured. Before disassembling the inverter module, it is recommended that the inverter module be photographed, as the photos will be used for reference during restoration. First, remove the terminal blocks on the inverter module. Remove the compressor wires. The copper bus bars are disassembled in the order shown above. Please disassemble the copper bus bars in this order. Hold the copper bus bars by hand to prevent the terminals from being damaged by reverse pulling force when disassembling the screws. Since the inverter module screws are soft, it is advised to use the electric screwdriver with a torque smaller than 0.78 nanometers. If the torque cannot be determined, use a manual screwdriver to remove the screws. The inverter module is disassembled in the order shown above. Please disassemble the inverter module in this order. Otherwise, the screws will be partially stressed and the parts may be damaged. Remove the inverter module after the screws are disassembled. After removing the inverter module, we can see that some thermally conductive silicone grease remains on the microchannel radiator. If the inverter module is punched and gets burned, metal impurities may be generated. Therefore, the thermally conductive silicone grease must be cleaned. Before coming into contact with a new inverter module, discharge static electricity on your hands. Otherwise, the inverter module components may be damaged. But how to get rid of the static electricity? There are 2 methods to do so. Wear an anti-static wrist strap. This provides a way for static electricity to dissipate without causing damage to the inverter module. Touch a earthed metal object, such as the metal case of the outdoor unit, to discharge static electricity. However, doing this, you may not release all of the static electricity in your body. 1. Before replacing the inverter module, apply thermally conductive silicone grease on the heatsink of the inverter module. The thermally conductive silicone grease usually comes with the accessories of the inverter module. If not, purchase it through the after-sales system. it is not advised to purchase the silicone grease available on the market. Using unsuitable silicone grease may affect heat dissipation of the inverter module, resulting in excessive temperature of and even damage to the inverter module. Apply and spread the silicone grease evenly at 200 plus or minus 50 microns. The standard criterion for the application is that the silicone grease evenly covers the entire heatsink surface. Thicker silicone grease does not mean better heat dissipation. Too thick application may adversely affect the heat dissipating effect. After the silicone grease is applied, it must look smooth without any heatsink surface exposed. The inverter module screws are arranged as shown in this figure. Please install the screws according to this figure. Otherwise, the screws will be partially stressed and the parts may be damaged. Since the inverter module screws are soft, it is advised to use the electric screwdriver with a torque smaller than 0.78 microns. If the torque cannot be determined, use a manual screwdriver to remove the screws. While installing the copper bus bars, refer to the schematic diagram for installing the copper bus bars on the sheet metal of the electrical control box. Compare the shapes and positions during installation, placed at a corresponding and fixed. To avoid interference between copper bus bars, install them accordingly to the serial numbers shown on the diagram. When installing the copper bus bars and compressor screws, please use the electric screwdriver with a torque of 2.5 to 3.5 nanometers. If the torque of the electric screwdriver cannot be determined, it is recommended to use a manual screwdriver for disassembly and assembly. During installation, it is necessary to hold the copper bar or conductor by hand. After prefixing the screws on the copper bus bars, tighten all the screws in sequence to avoid tightening one of the screws directly and causing other fixed positions to be pulled by force. After all the screws are installed, insert the terminal blocks into their corresponding ports. Special attention should be paid to the S7 DIP address. The left compressor module should be set to 00 and the right compressor inverter module to 01.